Today we're going to talk about metric conversions. So we're going to use our same notes that we made the other day. So we're going to look at how to change millimeters to centimeters to decimeters and how to go back and forth with those. So this is the only piece of information that we need for the metric system to realize how much of something is inside of another. So we're going to use that same when you go from a smaller unit to a larger unit, you divide. And we're going to use those same 3 steps that we talked about yesterday. When you go from a larger unit to a smaller unit, that's when you multiply, because you need more of them to fit in. So for example, there's more centimeters that are in a meter. So it is a larger number, so we're getting larger. So we're going to follow those same 3 steps that we looked at before. So find the S and the L, the smaller and the larger label. 2, use the conversion chart. So like look at how much each is equivalent to, and then you either multiply or divide. This time multiplying and dividing is going to be so easy if you understand the powers of 10 that we review every day. So let's look at our first problem. Eric can throw a ball about 2,300 centimeters. How many meters can he throw the ball? So I'm going to write down 2,300 centimeters. My question asked me to go to meters. Let's follow the same steps. Which is the smaller measurement? Which is the larger measurement? Smaller. Meters are much longer. We've been practicing using meter sticks in the classroom. So I'm going to set up my problem. Smaller to larger tells me that I need to divide. What am I going to divide by? How many centimeters are inside of a meter? I'm going to flip back and look. How many centimeters are inside of a meter? I'm moving over 2 spaces. So I need 1 with 2 zeros. This is 2 powers of 10 that I'm looking at. So 2 powers of 10, there's 100 centimeters. Well, if I'm dividing by 2 powers of 10, I'm going to shift my numbers 2 places. So really, it's going to get smaller by 2 zeros. 2,300 divided by 100 is 23. So that's my answer. I've shifted my numbers over 2 places. Since I'm getting smaller, they need to move in this direction. So the 2 goes to this spot, and the 3 follows. My decimal stays the same. The more we practice, the patterns of these will be easier. Let's look at another one. Barbara's book is 30 millimeters thick. How many centimeters thick is the book? I have 30 meters, and I'm trying to go to centimeters. So I have 30 millimeters, and I'm going to move to centimeters. Follow your same steps. Which one's smaller? A millimeter is smaller than a centimeter. So I'm still dividing. Now I need to see how many millimeters are inside of a centimeter. How many millimeters are inside of a centimeter? They're right next to each other. There's 10 that fit inside of a centimeter. So I'm going to divide by 10. Well, 30 divided by 10, that fits in 3 times. Let's move on. Let's practice another one on our own. Dolores can reach 2 meters high. How many centimeters can she reach? We have 2 meters. We're looking for centimeters. So you go ahead and pause the video, solve this one on your own, and then come back and check. Okay, you were correct if you labeled meters as larger, centimeters as smaller. Larger to smaller, we multiply. So what am I going to multiply by? How many centimeters are inside of a meter? Let's see if you found the right measurement. There's 2 powers of 10, 2 moves. 10 times 10 is 100. There are 100 inside. 2 times 100 is 200. Let's do one more on your own, and then we'll move on past length, and we'll move to either weight or capacity. Holly can take a giant step of 960 millimeters. How many centimeters? I have millimeters, going to centimeters. 960 millimeters, I'm going to centimeters. Do this one on your own. Follow your 3 steps. Let's check your work. Smaller, larger. Smaller to larger, I am dividing. How many there's not a centimeter inside of a millimeter. It's millimeters inside of centimeters. There are 10. 960 divided by 10, I'm shifting 1 power of 10. 1 power of 10. My answer should be 96. Let's move on and talk about capacity. So I'm using the same set of information, I'm just using different root words. Jana found the fish tank held 20 liters of water. How many milliliters of water did it hold? 20 liters, we're trying to find out milliliters. 20 liters, we're trying to find out milliliters. Let's go look. So I have liters, milliliters. Milliliters are smaller, liters are larger. When I go larger to smaller, I am multiplying. How many milliliters fit inside of a liter? 1, 2, 3. 10 times 10 times 10 is 1,000. 1 with 3 zeros, I moved 3 places. I'm not counting each one, I'm counting the moves. So I'm going to multiply by 1,000. So I need a larger number. That makes sense because milliliters are teeny tiny, so I need a lot of them to be able to fit. So 2 times 1 is 2. How many zeros do I have? 1, 2, 3, 4. 1, 2, 3, 4. Let's practice another one on your own. Her teacher asked her to give the fish some vitamins each day. If she gave them 35 milliliters each day, how many milliliters will she give them in a week? We're going to skip over that one actually. Let's move down to number 5. A truck brings fuel oil to school, which is stored in a 12 kiloliter tank. How many liters does the tank fill? We don't see kiloliters very often, but we can still work this problem. 12 kiloliters, and I'm trying to go to liters. 12 kiloliters, and I'm trying to go to liters. Which one's larger? Kilo is way over here. Let me add this to our list. I know we don't see this very often, but we could still work it. Kiloliters to liters. Kiloliters is a larger measurement. It's a smaller measurement. When I'm going from larger to smaller, I multiply. Let's look at how many of the smaller fit into the larger. 1, 2, 3. 10 times 10 times 10. 3 moves, 3 zeros. 2, 3. 12 times 1 is 12. How many zeros? 1, 2, 3. 1, 2, 3. Let's move on and work on, we're doing the same exact thing, we just have different root words. So we're still using the kilo, the milli, we're still using centi, we just have a different root word. We're talking about grams this time. This is why we have less to memorize when we're talking about metric. So we'll do these on our own. Beverly brought a tennis ball to school. It weighed 60 grams. How many milligrams would 3 tennis balls weigh? Well, I see I have a 2-step problem. Let's do 1 step at a time. 60 grams, trying to turn them into milligrams. 60 grams, how many milligrams? Go ahead, pause the video, see if you can make that conversion. All right, let's look at which one is larger. A gram is larger than a milligram. Larger to smaller tells me I need to multiply. How many milligrams inside of a gram? 1, 2, 3 moves. 3 zeros. My answer should be 6. 1, 2, 3, 4. 1, 2, 3, 4. But the problem said my second step. How many milligrams would 3 tennis balls weigh? So I need to multiply my answer times 3. Well, 6 times 3 is 18. 1, 2, 3, 4. 1, 2, 3, 4. Add my 0. 3 tennis balls would weigh 180,000 milligrams. Let's look at 2. Aaron brought a can of chicken soup that weighed, I'm going to skip over that one. Let's do 3. Rachel brought a troll doll that weighed 100 grams. About how many from her collection would make a kilogram? So I need to know how many grams fit inside of a kilogram. So I have 100 grams, and I want to change it to kilograms. 100 grams, how many of those are going to fit inside a kilogram? So I want to know how many can fit. Well, let's look at what we know. 1 gram, there are 1, 2, 3 moves, 1,000. So I know that 1 kilogram equals 1,000 grams. So I need to know how many of 100 will fit into that 1,000. So I could keep adding up to see how many would fit inside there. 100, another 100. I could keep adding up. Well, I already know that 10 are going to fit inside. So 10, what was the question? How many troll dolls? We would be able to fit 10 troll dolls. I'm going to flip over and let's practice. 2 more. And we're going to pause the video each time and you complete them. So Stephen's hair comb weighs 35 grams. How many milligrams? 35 grams? How many milligrams? 35 grams. How many milligrams? Go ahead and pause the video. All right, let's look at this. Gram is larger and this is smaller. When I go larger to smaller, I multiply. How many milligrams are in a gram? I've done this enough to know I'm moving 3 moves. There are 1,000. My answer should be 35 with 1, 2, 3. Let's move on to the last one. One of Harold's shoes weighed about 500 grams. How many kilograms would both of his shoes weigh? Well, I have grams. I need to know kilograms. But it says both of his shoes, so this is a 1, 2-step problem. I have to change it to kilograms, then I have both of his shoes. It's the word that I would have boxed, an action word for both, 500 grams to kilograms. Pause the video and go ahead and solve it on your own. Okay, we are smaller to larger. So let's look at 500. Smaller to larger means divide. So 500 divided by 1,000. This is larger, so I know my number is going to be a part. I know that 500 divided by 1,000, if I wrote that in a fraction, that would give me a half. But if I wasn't sure how to do that, let's draw some place value charts. How many places? 1, 2, 3. My number's getting smaller. I'm going to move it 1, 2, 3. My 5 would go here. I have half. This matches 5/10. It's a half. So it's equal to 5/10 or a half of a kilogram. So when my question says, what would both of his shoes weigh? So one is 5 kilograms, 5/10 of a kilogram. The other one is 5/10 of a kilogram. I add those together, I get 1 whole kilogram. So this would be both of his shoes. So, in my opinion, metric is much easier. You have one set of charts, and all you're dealing with are moving your numbers around. So what do you notice about every time we've done a problem and answer? Problem and answer. What do you notice every time we do metric system? What is the same? So if you said that the numbers are the same. Maybe instead of numbers, I should say the digits. The digits refer to one of them. Just shifted. So when we've talked about powers of 10, our numbers don't change. They just move place values. So the 5 just moves to a different place value. The 3 and the 5 move to different place values. This is what's great about the metric system. So we're not multiplying big numbers. I don't have to memorize a lot of conversions. I just have to know powers of 10, and I have to know how they shift around.